All right, so today is a day one lesson of variation functions. So our essential question is, how do I solve problems using direct and joint variation?
Sometimes, well, all the time, I guess you guys ask, why are we learning this? Well, you can use variation functions to determine how many people are needed to complete a task, such as building a home in a given amount of time. Can you believe that? Yeah, well,
Okay,
yeah,
I believe you.
okay, I'm not lying. So in chapter 2, oh my, that seems so long ago, Miss Boyd, you studied many types of linear functions. One special type of linear function is called a direct variation. And what that means, it's a direct variation. It's a relationship between two variables, x and y, that can be written in the form y equals k times x. Now, the important thing to note, k can never be 0. Okay? In this relationship, k is called the constant of variation.
All right.
Right? And how we word that y equals k times x, it says y varies directly as x. I know that sounds weird,
Yeah,
but that's exactly how you say it.
Okay.
Y varies directly as x. So the nice thing about direct variation is it's very, very similar to slope-intercept form. Y equals mx plus b. Well, we know there in that equation, m is our slope,
Right.
b is our y-intercept. So when we're graphing these direct variation functions,
Don't worry, we're back.
okay, our k is our slope.
We might have to pause for a second.
We might have to pause for a second?
Yeah,
Okay, here we go.
lost our writing. All right, we're back. We just lost the connection there for a second. Oh boy. All right.
So what I had just said is, in the equation y equals k times x, k is our slope. And our y-intercept is 0, because there's nothing added to it.
Okay.
And because the y-intercept is 0, we know that our line is going to go through the origin.
Right.
0,
0,
0.
Got it.
On the next page, we have an example.
Okay.
So given that y varies directly as x, the minute you hear that y varies directly as x, you write,
directly as x.
that's right. They tell us what y is, they tell us what x is.
Yeah.
Let's plug them in.
All right. Y is 27. So 27 equals k times 6.
Right.
Well, now we just solve that. Get k by itself, so divide both sides by 6.
Yep,
And
and
we get k equals what, 4.5?
4.5. Yep, leave it as a decimal is totally fine.
Okay.
So now look at the directions. It says write and graph the direct variation function.
Okay.
Once you find k, then you plug k back into the original equation.
Okay.
And so you write it as y equals 4.5 times x. It's like a two-step process.
Okay.
Now to graph this, remember what we said. The origin, the line is going to go through the origin. So
Right, 'cause
let's
that's
start
the
at the origin.
y-intercept.
Right. And the slope is going to be really 4.5 over 1.
Yep.
Maybe we write that, 4.5 over 1. So Miss Boyd's going to go up 4.5.
2, 3, 4.5.
And over 1. There we go. And
I
should we
can
go
go
down?
down.
1, 2, 3, 4.5.
And over 1.
There we go.
Oh
Oh boy.
I'm not going to be able to make that line.
Let's see.
Uh,
Nice.
Close.
That's it. That's all you're doing.
Oh, that's easy enough.
Okay. Example 2. Oh, never mind. It says, if k is positive in a direct variation, the value of y increases as the value of x increases.
Makes
So
sense.
obviously, if k is positive, your slope is positive, it's going to go up and to the right.
Right.
If k was negative, it would go down and to the right.
Right, yep.
Okay? Because we always remember, it's like reading a book.
Yep.
You read a book from left to right.
Got it.
Example number 2. I just want to quickly, should we save one
This
for
seems
class?
pretty
Because it's,
simple.
yeah. So example 2, we're going to save.
All right.
Now we're jumping to joint variation.
All right.
And what that is a relationship among 3 variables. So instead of just x and y, we now throw in a z.
Right, so that 3D we did before.
3-dimensional, right.
Gotcha.
It's still worded as y varies, now not directly, but y varies jointly as x
Gotcha.
and z. The phrase y varies directly as x and y is directly proportional to x have the same meaning.
Got
So
it.
back to the direct variation, I
before.
just threw in a little
Got it.
note, right? That means the same exact thing.
Okay.
Okay, next page. There we go. Example number 3. The volume V of a coin.
Cone.
Did I say coin?
You did. That's okay.
Sorry.
It's Monday.
Yeah, cone varies jointly as the area of the base and the height h. So right
we
away,
got a V, we got a B, and we got an H.
so let's
we
write
got
our
3.
equation. So notice it's not y equals k times x times z. It may not be,
Right.
right? Because now we're using
Well, that's
v.
our original. It would have been Y equals K times
Yeah.
X times Z.
But in,
But we filled in our V, our B,
right,
and
and
our
our
H.
h, okay?
Got it.
So there's the original equation. So maybe,
Okay.
okay? So now let's plug in what we know.
Okay.
We know v is 12 pi. We don't know k.
K.
We know b is 9 pi. And we know h is 4.
All right.
So now we're going to solve.
Okay.
We're solving for k.
So I'm going to
That's
just multiply these
36
first real
pi
quick. So we got 36 pi
times k.
K equals 12 pi.
Right,
Don't hit your pi button because look it, they're going to
Uh-uh.
cancel nicely.
right.
Divide by 36 pi.
Mm-hmm.
Divide by 36 pi.
Correct.
Those cancel.
Yep.
And those cancel.
Right.
So we're left with 12 over 36 equals K,
And that reduces
Or
to 1/3.
1/3.
Mm-hmm. So there's our k. So now what we're going to do is under step 2, we're going to rewrite the original equation, v equals, and instead of k,
Oh, we're
we're
plugging
going to
it
plug
in.
in what k is equal to. K is equal to 1/3
Here we go. 1/3.
times b times h. So now look at what it's asking us. Find b. Oh, you know, that really should have been, do
Should
you
have
want to
been a
change
big
that?
B. Yeah.
Mhm.
Find
Yeah.
big B.
Because I think, yeah, exactly. It should have been, that was a typo.
Let me just start over here. There
There,
we go.
so change your notes, please, to reflect
Yes.
that.
So we just plug in the stuff we know.
Yep, so
except
we
for B.
know, now notice, we don't go back and use the original 12 pi,
No.
because
we're
it's saying,
using when.
find b, big B, which
This.
is the area of the base. Now, when the volume is 24 pi,
Okay, so we got 24 pi equals 1/3. B we're still trying to
Mhm.
find.
and
Times H is
9. Right, so we multiply the right side.
We get
1/3
3.
times 9 is 3b,
B
equals 24 pi. Still do not plug pi into
No,
your
just leave it
calculator.
in pi.
Your answer is going to be in terms of pi.
So it cancels. We get B equals 8 pi.
And what would our unit be if if big B is area of the base?
Well, since it's an area, it would be feet squared.
Right. Exactly. And now we're done.
Okay.
Notice a lot of these problems are 2-step problems.
Okay.
Nothing is there. We'll look at that.
Short video.
Yeah, so here's video question 1, video question 2. Pretty straightforward. They're
Yeah,
both, I
direct
didn't, no joint
variations, so-
variation, they're both direct
So
variation.
just your Y equals KX.
Yep.
All right.
Have a great
see ya.
day. See you tomorrow.